All right. Our last section, 2.5, further applications of right triangles, aka more word problem. Okay. All right, so we're going to be talking about what are called bearings. Okay, there are two methods for expressing bearings. When a single angle is given, such as 164, it is understood that the bearing is measured in clockwise direction from north to south. So when you're talking about bearings, it's how planes and boats, how they navigate. Okay, and it's based off our never eat soggy waffles. Your teachers didn't learn to do that for north, south, east, west. Yeah. What did your teacher say? Yeah, I mean, worms. Oh.
I can't say my orange.
It's not funny. It just caught me off guard. I was like, what do you mean? You can't, I thought you just said it. And then you said it again. And I was like, oh, I see. All right. Nor never eat soggy waffles. This is how my teachers taught it to us. And so you're north. And so normally when we're talking about angles, it starts on our positive x-axis and rotates counterclockwise. Bearings do not. Okay, bearings go clockwise, starting from north, and go bam, 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 bam. Got it? Yes.
Will it say bearings if that's what we?
Yes, if you're talking about if you're as soon as you see north, south, east, west, you know that you're talking about bearings. Okay. So I just want to stress that out. Are we comfortable? We're good. And sorry for laughing about worms. I didn't mean to. You caught me off guard. All right. So here we go. It says radio stations A and B are on east-west line. Okay. So this tells me right here that I'm dealing with bearings because it's using some form of direction. Does that make sense? All right. So A and B are on east-west line, 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. Station B simultaneously detects the same plane on a bearing of 331 degrees. Find the distance from A to C. So let's talk about what this picture looks like. So A and B are on your east and west line. Does that make sense? So they're across from each other. All right. From angle A, it has its own bearing system. It has its own, like if you're on a GPS, your north, south, east, west is not going to be the same GPS as someone else, right? I'm heading north from here and you're heading north from there. So angles A, this is their north, and it's going 61 degrees is where they see the plane. Does that make sense? Okay, let's try it again. Are you good with A and B being here? Based on the fact that it says east-west. Okay, the next thing it says that they're 3.7 kilometers apart. I labeled it 3.7. Then it says station A detects a plane C on a bearing of 61 degrees. Your bearing comes from identifying your location, starting at the north and going that number of degrees away, clockwise. So we're at the north and we go 61 degrees. And it goes up. This is where C is. It's from where you're at. So like I'm right here. I have my own north, south, east, west. You're over there and you'll have your own north, south, east, west. So you're facing a different direction. Your view is different than mine. Does that make sense? Yes. Okay. So then at B, it says that its bearing is 331 degrees. So B, with its north, I'm going 331 degrees. And that's where it sees angle plane C. And when I connect it all, it creates a what? A right triangle. The hard part is the drawing. Once you've drawn it, it's just now right triangles. Okay? Because it's going to be parallel to each other, you now create your parallel rules, your opposite interior, same side interior, your alternate interiors. All those come into play. Okay? So if I know that this is 61 degrees and it's at a 90-degree angle, then this has to be 29. If this is 29, then it has to be 61. So now I know all of the measurements on the inside, 29, 61, 90. I know my long leg, my hypotenuse. And it wants to know B. Can we find B? So this is our goal, is to find B. Based on our given information, we have an angle here and an angle there. Does it matter which one we use? No, it doesn't. So if I use angle A, what's the relationship between B and A? Adjacent in, which would be, I would use cosine. If I use angle B, what's the relationship? Opposite hypotenuse, so I would use sine. So either one are going to be the same. So if I have the cosine of A, we're looking for side B, equals B over 3.7, or I would use the sine of B equals B over 3.7. Either one would result in my answer. Okay, so we know that 3 7/10 cosine of 29 equals 3 7/10 sine of 61. So approximately, what is B? What we get? And why are we doing 3.2? 2 sig figs. Good job. 1, 2, 1, 2, 1, 2. Which part are we holding on to? So we have 3 7/10 sine of 61, or 3 7/10 cosine of 29. And based on our given information, we're gonna stop at 3 and 2 kilometers. 3 2/10 of a kilometer. Okay, all right. I'm a strong person with method number 1, where I'm giving each one their own bearings. I'm supposed to teach you method number 2, where you're trying to do everything from the same bearing, the same north. Okay, which we'll talk about. But are we good on example 1? What all over? Sure, if you can specifically tell me what part. Like the picture, the I don't want to say the same thing exactly the same again. So I need to know where you got lost. Otherwise, I'm really going to repeat myself and you're still going to be lost.
Yeah, that's fine. I kind of just cut in like in the middle, like, you know, too busy drawing picture. Oh.
Okay, so we drew the picture from A to B, labeled it 3.7 kilometers. We found the north at A and went 61 degrees bearing. And that lets me know that's how far C is from there. Then we went to B. We found the north at B and we went 331 degrees bearing. And we found that that's where the plane is from there. We connected to make a triangle. And from that triangle, because it's all on 90-degree angles here, I know that if this is 61, then this is 29. And if this is 29, then this has to be 61.
Oh,
Because they have to equal 90 together. 180 is all 3 of the angles. But when you have a 90-degree, the 2 smaller angles have to equal, they're complementary. Now I just have a right triangle and we're using our trig of right triangles to figure out our missing side. From here, we have angle A. I'm looking for its adjacent given its hypotenuse, which means I could use cosine. From angle B, I'm looking for its opposite, but given its hypotenuse, which means I can use sine. So you can use either one of these. So you either can do cosine of A or you can do sine of B, whichever one you choose, because they're gonna both equal the same thing. And then we model that they both equal the same thing. All right. Questions about example 1, method 1. 2. Just told you there's another method.
You like method 2 though?
I like method 1. All right, here, it is very important that you correctly label. Can't stress it enough. If you do all your math right, but you put the wrong thing in the wrong spot, okay, it's not gonna work. All right, so the second method for expressing bearings starts with a north-south line and uses an acute angle to show the direction either east or west. So basically you are only focused on acute measurements.
That sounds like that's too many more steps.
So many. All right, so we're only looking at acute measurements. All right. We're going to jump to here, ignore the ones in between. Did I delete the problem? Guys, I think I just deleted the problem because I didn't want you to focus on that method. I figured only teaching you one method would be safe.
That's all we need.
Okay. So we learned one method. Last part is just combine angles of elevations. So now we're on combined. Notice here now, and not only do I have one triangle, I typically have 3. Do we see that? I have 2 rights and 1 scalene. Here we go. Not scalene, obtuse. Francisco needs to know the height of a tree from a given point on the ground. He finds that the angle of elevation to the top of the tree is 36.7. So the first point that he marks here was A. Okay. So from a given point, he doesn't know how far, but from here, the elevation is 36.7. He then goes 50 feet backwards. So he goes backward 50 feet. And he finds that the elevation here is at 22.21 degrees. Find the height of the tree. We have a lot of unknowns now, guys. Oh no. What do we do? No, don't be a quitter. Anyone? Anyone? What do you think we do? Find the angles. Yeah, we can find angle B fairly easy. And we can find the other side of angle A. Why can I do that? They have to equal 180, right? So first, starting here, I can find the measure of this angle. Does that make sense? How can I find the measure of that angle? There we go. So we're going to do 90 minus 36.7. And what does that give us? 53.3. Okay. That angle is found. Because complementary 90-degree angles, the 2 angles have to be complementary, which means they have to equal 90. 90 minus 36.7. That's what I did. Is that not what I did? Oh. Okay. Now we're going to find the next angle we can easily find. These 2 angles. Why can I find this angle? It has to equal 180. These are on the same line. They're supplementary, right? So these 2 angles have to equal 180. So we have 180 minus 36.7. And what does that give us? 143.3. Because they're being trapped inside and they don't know how to handle it. I don't know. That's my conclusion. I could be wrong. All right. Then our last angle. How do I find that one?
You don't know?
I'm asking you. How do I find it? Perfect. Good job, Johnny. All 3 angles have to equal 180. I know this one and I know that one. So to find angle B on the outer side, They are being real loud today. Minus 143.3 minus 22.2. And what does that give me? Something. Y'all have the calculator. I believe in you.
14.
All right. So I've now eliminated some of my unknowns. I now have angles. Because I have angles, can I now find sides and heights and all whatnot? Yeah. So first we're going to find, the X and our H. So we got to find X and H. What can I do? Okay. Do I have measurements though? I can do adjacent over opposite. That's tangent. So I know that the tan of the two have to equal something, right? Okay. So keeping that in mind, we know that the tan, can I call this angle A? Okay. So the tan of A of 36.7 equals my opposite, which is H over X. Okay. What else do I know? Where can that come in? So that, if I use 22, it would be the tan of, it would be tan of X plus 50. So if I use the 50, tan of 22.2 equals, and the opposite is H. And its adjacent is, like Johnny said, X plus 50. Okay. I now have two unknowns, but I have two equations. Do you guys remember how to find two unknowns of two equations? You can do substitution. Oh, well, what do you want to eliminate? Substitution and something with a calculator. Anyone? What happens if you graph and you look for where they are friends? The intersection.
How do you put H in a calculator?
You let it be Y.
Oh,
You let it be Y, silly guy. All right. So if I want to find this, at this point, basic math, go back to finding intersection. Okay. I need to get H by itself, and then I'm going to graph and find where it intersects. Does that make sense? All right. That's because these two is tan of 36.7. Tan of 36.7, that's just a number, right? Tan of 22.2, that's just a number. So that's perfectly fine. So H by itself here, H equals X times the tan of 36.7. H of this one is what? Mm-hmm. Tan of 22.2. And now we're just going to graph these. So Y1, Y2, find their intersection. You definitely can. So we're going to go to our handy dandy calculator. Now, the way I'm supposed to teach you this is just long and drawn out. And this is the most direct route to be. So we're going to put in X, tan, 36.7. Enter. We're going to put in parentheses X plus 50. Tan of 22.2. I got it all in there. And now I'm going to do what? Graph it. It's not a good graphing window. Going real slow. Sylvie just be graphing so slow.
I think you need to upgrade.
I think she's just slow at graphing. I need to zoom out. Graph. Stop it, Sylvie. We're gonna zoom. Let's try zoom fit if it'll make it magic happen for me, which is 0. Find my intersection, Sylvie. I believe in you. I think you froze on me. Oh,
You said Zoom.
zoom 0 to see if it'll automatically find it for me. It's going.
I would say,
Sylvie, you can help me be great. All right. Where are we at in this world? She's all the way at 22. Let's go up to, I don't know, 100. And we'll count by 5s. And then on my X, I'm just going to be drastic and go all the way up to 50. And we'll count by,
I think it is like,
and we're going to hit graph. Let's see. Y'all see how slow she draws?
slower than you.
Slower than usual. I don't know what old girl is doing. Ooh, are we gonna hit? Oh. Let there be intersection. Let's change my X max to 100. Y'all got
There we go.
64?
you got 60.
Ooh, I got an intersection. All right. So what does X equal? Second, trace 5. Yes, Sylvie. Yes, Sylvie. Yes, Sylvie. I got 60.5. Did y'all get 60.5? So X equals 60.5. So now that we know the value of X, what's the height? It tells us. What did it say? 45.1. We know that the height is 45.1 feet. Oh, it says nearest foot, so just 45 feet. And there we go. All right, so I was supposed to do like a whole drawn out thing of H minus this and minus that. And I was just like, we're just going to talk about things you should already know. Create 2 equations with the same variables, solve for one, find the intersection. Okay. The intersection will give you all that you need to know. All right. That is the end of 2.5. That is the end of our unit. You have the rest of the time in here